Remember how I emphasized, look at my free presentation for one of these webinars that I gave, when I talk about how the 60 Hertz transformer has automatic flux balance and automatic charge balance, because it is driven by the sinusoidal voltage, which has a zero DC bias made by Tesla generators to make sure that there's no DC bias current in it. And because of the way how the transformer works, you know, you have forget about Lenz's law. It is automatic because of dot connection, that the current coming out of the dot in a secondary is reflected on the primary as a current coming into the dot. So the reflected secondary current minus reflected secondary reflected current plus a primary current difference is a magnetizing current. And that's that magic of a transformer, that when it is charge balanced and a flux balanced, doesn't store energy. Or let's put it this way, it has a small circulating current on the input, which essentially generates through transformer through Faraday's law. That small current generates a flux in the core. And the flux in the core by Faraday's, put here, again, concept of a 60 Hertz transformer. By Faraday's law, you have magnetizing inductance, which is large. The core has no gap, primary and secondary, N1 and N2. So what happens is then a voltage in a 60 Hertz, the voltage on the input is the sine wave voltage. Sine wave voltage here generates, by definition, VL, L di per dt, Ln, di magnetizing per dt is a voltage on the input, voltage of generator, right? In sequence of the things are, this voltage source is driving, AC driving voltage source. It generates this current. This current generates, this magnetizing current generates the flux in the core. There is only one flux, not two fluxes. And according to Faraday's law, this flux, N1 d phi per dt, is voltage induced by Faraday's law, which is opposing driving voltage. You see what I'm saying? So you have driving voltage, and then you have this voltage, N1 d phi per dt. So there is a whole circuit balance. Input voltage generates a flux in the core, and that flux in the core generates unique flux in the core, which makes everything possible. That, by Faraday's law, this flux generates a voltage which is opposing driving voltage and make it, in a loop equal. But if you put extra winding here, what happened? This one generates N2 and same flux d phi per dt, which is generated on a second winding, right? So now you have and so far you don't have any load on the output which is open. Then what happens? In this open load, all you're seeing is a small current on the primary. So the open, so transformer, 60 Hertz transformer operates in such a way at night, there is nobody's using electricity. That's what happens. And you have this current here in magnetizing, so-called magnetizing current. It's a wasteful current. And that's why the people in a 60 Hertz transformer, there was a push to say, oh, can we make now magnetic material, which is 10 times higher magnetizing current or magnetizing inductance by making a permeability of the core 100,000. Like 60 Hertz core have a permeability of 100,000. So 60 Hertz was great because you have a huge inductance and therefore small magnetic current. Later, that wasn't good enough. Iron cores were not good enough. So there was some magnetic manufacturer invented called met glass. And met glass has a 10 times smaller, magnetizing current. So this wasteful current during the night is reduced 10 times. Well, it's not great. That's great because now you're reducing weight when it's operating open loop. But what's the key point of this magnetizing inductance is that it is same irrespective. So if I put a high current here on the output, 100 amps sinusoidal current out of a sinusoidal voltage, if I put that here, and I put now the sinusoidal voltage and divided by resistance in sinusoidal current, that current is reflected on input, but magnetizing current stay constant. So I want you to understand how stupid it is when a Professor Emeritus and others come, oh, the magic, and there is a don't allow transformer to magnetizing current to saturate. There was no saturation magnetizing current. This is nonsense. This is part of the little extra current drawn from a source, which is actually enabling this magic transformation of all input power to all output power, and according to Maxwell, happens at the speed of light. And that's why you can have Niagara Falls AC high voltage transmission, send it a few thousand miles to California and use it in a 60 hertz transformer, okay? Now, did anything change? And let me just copy this. Now, when I copy it, I want to tell you one thing.
Professor, excuse me, one question before you continue. Do we need to provide on both primary and secondary of this transformer the resonant inductance, or it is automatically provided by the current ratio? Do we, because now when we put isolation, the resonance inductor is on the right side. Do we need to put it also on the left side?
Okay, I'll answer it directly, and we'll go through detailed explanation of it, because one thing is what Professor Surgeon is saying. General model of transformer has a leakage inductance of primary and leakage inductance of secondary. I'll give you the answer, correct answer, and then I won't do a lot of justification. When we get to the magnetics, you'll learn more about it. So we are kind of giving you the view, initial view. This is a general model of transformer. However, 60 hertz people used model of a transformer which has, if you reflect secondary inductance on a primary, right, then you can have a model where a secondary inductance reflected to primary will result in a LL1 plus, let's call it turns ratio N12/2, and let's call this LL2 reflected. There will be this inductance reflected by turns ratio square will be inductance on a primary, and let's call it L2 reflected. 60 people will prefer model. In fact, that was my problem when I invented coupled inductor. So I just give you upfront view. They used LL1 plus reflected inductance secondary as a single inductance LL primary, leakage inductance of primary. And they never used a model that leakage inductance is separated on primary and second, even though that is correct model. In fact, I found that model many years later. MIT published in 1943 book Magnetic Circuits. And in 1943, they published book Electric Circuits, which are much better than anything else published afterwards, especially magnetic books, magnetic. And I actually had some people from Honeywell. They had old guys like me, but that was 30, 40 years ago. They had the original book, Magnetic Circuits, so they subscribed to me and gave it to me. And then in that magnetics book, they made a correct model which says leakages are on both sides. And what is the practical aspect, what I'm just saying you when you ask the question? Practical aspect is the 60 hertz people didn't care that there was so much leakage on one side and so much leakage on the other side. Why? Because there is a common flux, but a common flux says part of that flux is it's coupling from input to output, but also when you drive secondary, part of the secondary drive is coupled to the primary, but a couple of so you had a leakage flux on a primary winding, leakage section of secondary. That's a true physical fact, But why didn't they care about this distribution? They only cared for the sum of these two, reflected sum on the primary side. What if this transformer is shorted? Why do they care how much of that is on primary, how much on secondary? They don't. They care that the total leakage inductance is large, right? Because when it's had a sudden short, windings on a 60-Hz transformer get, for whatever reason, insulation get cut off, and you get a short on a secondary. Now you have in a 60-Hz even line, you have a sudden short on the line. What's going to happen with this 100 kilowatt or a megawatt transformer? You don't have a circuit breaker which is fast enough to break the thing, and you're going to have either a fire or you're going to have explosion, right? Because you have a bomb, right? So what they actually wanted a leakage inductance be 10% or more of a magnetizing inductance, because leakage inductance will be the only thing when during the short we'll say there is no sudden short circuit, because there will be still inductance in this loop which will hold it enough before it's saturated completely so that you can turn off with a circuit breaker. So that's one reason.